So today we are going to learn two important ideas, quadratic equations and something called the discriminant. So as we already know, a quadratic equation is any equation that can be written in the form ax squared plus bx plus c, where a is a non-zero constant. An example would be x squared plus 2x plus 5 equals 0, and this would be considered a quadratic equation because the highest degree of x is 2, and it satisfies the condition that a is not equal to 0. In this video, we are going to learn more about the nature of the roots of quadratic equations and to determine whether there will be repeated roots, two distinct roots, or no real roots at all. Before learning the nature of these roots, we must first understand the quadratic formula, where x is minus b plus or minus root of b squared minus 4ac over 2a, where a, b, c are constants and a is a non-zero constant. Let us consider the equation x squared plus 4x plus 4 equals 0. In this equation, you can complete the square for this quadratic equation and get it in its factored form, which is x plus 2 entire thing squared is equal to 0. If you solve for x, x will be equals to negative 2. As you can see, there is only one root, and as per rules of maths, because the highest degree of x is 2, there must be two roots. And what this shows is that this equation has a repeated root, and that repeated root is x equals to negative 2. If we graph this, where this is the x-axis, this is the y-axis, it would form a graph such as this, where it just touches at x equals negative 2. As you can see, there's only one repeated root. In a situation like this, the discriminant should be equal to 0, because it is only when b squared minus 4ac is equal to 0, there would be a possibility of one single root. Think about it. When b squared minus 4ac is equal to 0, it means that the square root of this 0 would eventually evaluate to 0, thus cancelling this entire part out. So the only valid solution, as by the quadratic formula, would be minus b over 2a. And by using our constants a and b, which we already know from this equation, where a is 1 here and b is 4, if we substitute a and b into this equation here, we would get minus 4 over 2 times 1. And that would eventually evaluate to minus 2, which is the solution that we obtain by completing the square. What this shows is that in order for a quadratic equation to have repeated roots or single root, then the discriminant must always evaluate to 0. Thus, b squared minus 4ac must always equal to 0. Applying this logic to the situation of this equation, we can simply substitute a, b, and c to this equation here and show that it is true. b would be 4, a would be 1, and c would be 4. 4 squared is 16, and minus 4 into 4 is 16. And this eventually evaluates to 0, showing that it is true, and that means that when b squared minus 4ac is equal to 0, there will always be repeated roots in the quadratic equation. Previously, we considered the possibility of repeated roots. Now let us consider the possibility of having two distinct roots. Considering the quadratic equation x squared plus 5x plus 6, by simple factoring, this can be factored into two linear factors, which will be x plus 2 and x plus 3, which will be equal to 0. And for this equation to be evaluated to 0, both of these linear factors must equal to 0. So by solving it, x plus 2 will be equal to 0 and x plus 3 is equal to 0. So the solutions for this quadratic equation is x equals to negative 2 and x equals to negative 3. As you can see, these are two distinct roots. They are not identical, but they are real as well. In a situation like this, b squared minus 4ac will be greater than 0. Let me show you. In this example of x squared plus 5x plus 6, when you substitute a, b, and c into the equation, and if you evaluate the discriminant b squared minus 4ac, the b squared minus 4ac discriminant will be greater than 0. given that it's greater than 0, because there's a possibility of getting two answers, both a negative and minus b squared minus 4ac, this can produce two solutions. It can either be minus b plus root b squared minus 4ac over 2a, or x equals minus b minus root b squared minus 4ac over 2a. So this gives us rise to two solutions. In a situation like this, if you consider the graph, the quadratic equation will cross the x-axis at two distinct points. In this case, at minus 2 here and minus 3. Let us consider this quadratic equation x squared plus 4x plus 5 is equal to 0. If we are looking at the quadratic formula for this equation, in order for us to have no real roots, the discriminant must be less than 0. Think about it. When b squared minus 4 is less than or equal to 0, this means you are taking a square root of a negative number. As we all know, when we take the square root of a negative number, you get an imaginary result. As for example, the very basic value of minus 1. If you are taking the square root of negative 1, the resulting value will be I, taking us to the imaginary world. Same case here. When you are taking the square root of any negative number, there will always be an I included, meaning us that the solutions are taking us to the imaginary world. Hence, there won't be no real roots. If you consider this quadratic equation, and if you sub in the values of a, b, and c to the discriminant, you will always see that the discriminant will evaluate to a value less than 0. Here, a is 1, b is 4, and c is 5. Let us evaluate the discriminant. The discriminant, as said before, is b squared minus 4ac. Also, an important notation to discriminant is delta x. Usually, in further pure maths, the discriminant is often notated by the value of delta x. So now, if we evaluate the discriminant, delta x will be equals to b squared, where b is 4, entire thing squared, minus 4, a being 1, and c 5. So here, 4 squared is 16, and minus 4 into 5 is minus 20. And the resulting value will be minus 4. If you square root minus 4, then you get a value of 2i, which is imaginary. This is not a real root. This is the reason why when b squared minus 4ac is less than 0, it will provide imaginary roots. So as you can see, when b squared minus 4ac is less than 0, there are imaginary roots, and hence there are no real roots. So the condition for not having no real roots in a graph, usually graphs with imaginary roots follow the usual order, with no intersections with the x-axis, hence no real roots. Let us complete the square for this quadratic equation here. If you complete the square for this quadratic equation, then you get x squared plus 2, x plus 2, entire thing squared, plus 1 is equal to 0. By using the standard form for completing the square, you can see that the minimum value will be 1, and the x-coordinate at which this minimum occurs is minus 2. Therefore, the graph will look like this. Hence, it does not touch the x-axis, and thus there are no real roots. Thank you for watching this video, and I'll see you in the next video.